Welcome to this video. In this video, we are going to see about determination of friction loss due to fittings, bendings, and elbows. As we seen in before experiment, it is considered as a minor loss. The major loss will be considered using frictional loss due to the length of the pipe. Here we are going to see about these bends and elbows and fitting of the pipe. How we are fitting here, how we are passing the pressure and how we are reducing the pressure is also will affect your discharge of the pipe through the pipe. Sorry, discharge through the pipe. Here also we are going to follow the same procedure as we followed before. First we have to level this YouTube manometer using these two valves. Afterwards we can start the experiment. For first, we are going to take different kind of calculating values readings here. First, we have to take for these two are called as a small bend and this is your large bend. Okay. First, we have to take a calculation for a small bend by opening this inlet wall and closing this outlet inlet wall. For smaller bend value, we have to open this wall and close this wall. For a small larger value, we have to close this wall and open this wall. After opening alternatively opening this two walls, we can note down the reading from your YouTube manometer, and again we have to take close this wall and continue. After we closing this valve, we are going to take a 10 centimeter rise in this tube. The time taken to rise water in this tube for 10 centimeter. We have to repeat for the larger bend also. For fitting purpose, we can close this. For fitting purpose, we can close this wall first, and first we have to close this wall. We can take fitting through this reading, and afterwards we can close this wall and open that wall to take the other fitting readings. By using these readings, we can calculate the value due to loss for bending and fitting and elbows. We can see the calculation part in this remaining part in the calculation part.
To determine the losses due to bend, elbow and fitting, we first have to calculate the uh, discharge of the process Q, which is equal to A into R divided by T. Again, A is the area of collecting tank and R is the head of collected water in a tank, which is 10 centimeter, and time taken for 10 centimeter rise of water in the collected tank. Again, first we have to identify the velocity of the fluid in the small pump, which is considered as V1, equal to, it can be calculated through Q divided by A1, small a1. The small a1 is considered as the area of small pipe, and we have to calculate V2, which is velocity of fluid in the large pipe, through the formula Q divided by A2, which is A2 indicates the area of large pipe. Then we are going to identify the minimum minor loss in bend, which is HP equal to K into V1 square divided by 2G. Here K is loss coefficient, which is a constant, and G is the specific gravity in meter per second square. Then we are going to identify the minor loss in contraction. HC is equal to HC is equal to K V2 square divided by 2G, and and again we are going to identify the minor loss in enlargement. HE is equal to K into V1 minus V2 the whole square divided by 2G, and the final one is the minor loss in elbows. HD is equal to K into V square divided by 2G.